Okay, so this is what we're going to do. I'm going to go ahead and use drop this f of x here and just write y. Okay, so this is what we're given, and we want to find its inverse. Well, here's the technique that we want to use. We're going to flip the y and the x here. We're going to exchange them. Put the y here and the x here. Okay? And then all we're going to do now is we're going to solve for y in this equation. And that means that I'm going to take this 1 over to the other side. And then I'm going to multiply both sides by 1/3. So this is going to be the technique that you use to finding the inverse. And so we have y is equal to, now I'm going to write it like this. It doesn't matter how you write this, but I'll just write it like that right there. Okay? And so we have y is equal to x minus 1 over 3. And you know, usually the most appropriate thing is to write the dependent variable on the left, x minus 1 over 3. Alright, now let's actually look at a pattern here real quick. I am going to write this differently because I just thought of something. I'm going to go ahead and write this as 1/3 x minus 1/3. Now you notice the slope of our line here. The slope is m, so remember we defined m to be the slope is 1/3. And let's go back up here and look at this. So we're just identifying a pattern. And you notice the slope here is 3. Okay? So in our inverse function, the slope is the reciprocal of the slope of our original. Alright, so let's keep that in mind, because that could, I don't know, could help us out at some point in time. But what I'm going to do now is I'm going to go ahead and graph both of these so we can kind of look at what the graph looks like. So we're going to graph the original up here, and then we're going to graph the inverse. And we said that the inverse was 1/3 x minus 1/3. So let's graph both of these and take a look at the graph. Okay, so here's the graph of our two functions that we just graphed. I don't know what that is. Oh, these are places, I guess, where it crosses the x-axis right here, I suppose. Anyway, if you notice, remember when we plugged 0 in, we got 1 out. So in the inverse, if we plug 1 in, we get 0 out. So you see that? Okay. So let's see. This line here is the 3x plus 1. Okay, this is the 3x plus 1. In this graph here is the 1/3 x minus 1/3. Alright, and you can always tell if these two are inverses if you just graphed y is equal to x. Now I'm going to do that. I'm going to graph y is equal to x. Okay, so the green line here is y is equal to x. Now if you notice, this side is a mirror image of this side here. So if you could pretend this is an edge of a mirror, you know, you would see this would be, they'd both be a mirror image of each other. Okay, so that's one way to look at this. And now I'm going to show you a way to test if two functions are inverses of each other using what's known as the composition of function. Okay, the composition of function. If you looked at this here, when we take 4 and we plug it into the function, we get 1 out, right? So that means that if we take 1 and plug it into the function, let's see, yeah, we get 4 out, which is right here. Okay, so that was that x comma y, right, and y comma x. They're both inverses of each other, remember? Okay, alright. Okay, so this is how we're going to test if they're both inverses each other. F of f inverse of x, do you see this, is equal to